Welcome back, everybody. This is part 2 of the notes, or the back of the notes, starting with example C. Directions. Write the equation of a circle centered at 0, 0 with the given information, then sketch the graph. We're going to get a little more tricky now. Now we're going to give you the circumference. If the circumference of a circle is 8 pi, I want everybody to remember that circumference equals 2 pi r, or pi times diameter, right? So if the circumference is 8 pi, we're going to solve this equation for the radius. Now, most of you are going to be able to do this in your head, but let's act like you don't know how to do that. If I divide both sides by 2 pi, I'm going to get the radius equals, well, this all cancels, and 8 pi divided by 2 pi, the pi's cancel. The radius is just 4. Now, some of you smart cookies can already tell if the circumference is 8 pi, 8 would have to be the diameter. 8 divided by 2 gives you 4. But if you can't handle that, don't be afraid to solve this equation here on the side. So if the radius is 4, my equation is going to be x squared plus y squared equals the radius squared. Simplify is going to be x squared plus y squared equals 16. Now, on to the graph. We could do that little trick where you cover it up with your finger. Your y-intercepts will be positive, -4. I can cover this up. My x-intercepts are going to be positive, -4 again. But in all seriousness, if we know the radius is 4 and it's centered at 0, 0, I'm just going to go up 4, down 4, left 4, and right 4. Obviously, I can't count because that's 5, but that happens. So up 4, left 4, down 4, and right 4. Please ignore these 2 points. I'm going to draw the best circle I can. Nobody's perfect. And that's a circle with a radius of 4.
Okay, now the next one here, we've got different little concept for you guys to remember about a circle. This is giving us the area of the circle equal to 49 pi, We need the radius to be able to write the equation of the circle. So what I want to do here is recall that the area of the circle is pi times the radius squared. That's your area. And what I want to go ahead and do here, since I've been given the area, is I'm going to go ahead and say 49 pi equals pi times the radius squared. So if I'm going to solve this little guy right here, I'm going to just go ahead and divide both sides by pi, cancel those guys out. We're going to get 49 equals the radius squared, and then we know we want to take a square root here. Now, I'm not going to put a plus and minus in front of this, only because if we're talking about a radius, we're talking about a length. So I don't want to have a negative length represented, so I'm going to just have my radius being 7. If you know your radius, then you're good to go on writing the equation of the circle. So it's centered at 0, 0, so it's just going to be x squared plus y squared equals my radius squared. Now I'm going to go ahead, because I just ran out of space because I was writing too big, I'm just going to go ahead and write the 49 right there, but where I'm getting that is the 7, which is your radius squared. Now, just like Mr. Shramick was saying a second ago, I can do the whole cover-up thing, find my intercepts that way by taking y squared equals 49 square root plus or minus 7, same thing with the x, but we know the radius is 7, and we know it's centered at 0, 0, so let's just count 1, 2, 3, 4, 5, 6, 7. 7 right, 7 left, 7 up, 7 down. 1, 2, 3, 4, 5, 6. So it looks like it's going right to the corner of these graphs. 1, 2, 3, 4. And right there. And just do your best. It's not going to be perfect. That looked really bad, sorry. And if you'd like to, these segments, that's 7. That segment, if I drew it in there, radius is 7 anywhere around the circle there. And we're going to move on to example 3.
So far we've been graphing just circles, and circles are obviously, very perfect. If you notice in a circle as well, notice the coefficients out in front of x and y were always the same number. In this case, there was no number out in front of x and y. If you have a coefficient in front of x and y that are completely different, that's going to take your circle and make it more of an oval shape. But oval is kind of a middle school word. We're going to call it an ellipse. An ellipse is like an elongated circle. So on the next equation, it says graph the equation, then find the domain and the range. I'm going to do the same cover-up tricky to find the intercepts. If I cover up the 4y squared, I get 9y squared equals 36. I'm going to write that down. 9x squared equals 36. I'm going to solve that for my intercepts, dividing both sides by 9. I get x squared equals 36 divided by 9 is 4. And when I square root both sides, I get x equals positive negative 2. So my x-intercepts are going to be left 2 and right 2. So from the center, left 2, and from the center, right 2. To find my y-intercepts of my ellipse, I'm going to now substitute 0 in for 9x squared. Substituting 0 is going to just completely delete that term. I'm going to get 4y squared equals 36. When I divide both sides by 4, y squared equals 9. Take the square root of both sides. Don't forget your plus or minus. The y-intercepts are at positive and negative 3. So from my origin, I'm going to go up 3. I'm going to go down 3. And there's no real easy way to do this. You want to do your oval shape or your ellipse as best as possible. I'm just going to kind of start at the left, hook it at the bottom. There's no perfect way to look at this, but it should be pretty oval shape when you're done. All right, it should kind of look like an unhatched egg. So, domain. And for your domain, you're looking from your far left to your far right of the graph. There's nothing past negative 2, and there's nothing past positive 2 for your domain. The domain are the x numbers between negative 2 and 2. And how do you write between negative 2 and 2? In algebra, we say x is, well, it's between negative 2 and 2. Remember, that's our compound inequality for the domain. The range is from your south to your north. The graph on the bottom goes from negative 3 on the bottom to positive 3 up top, nothing beyond that. So in English, we say it's between negative 3 and 3. In algebra, we'll say y is between negative 3 and 3, or negative 3 is less than or equal to y, which is less than or equal to 3.
All right, and right here we've got another practice ellipse for you. I know this is an ellipse right away because I know these two numbers, they're different, and I'm adding between. So it's similar to the equation of a circle, but the two numbers in front of x and y are going to be different. That's how you know you're going to have it stretched out a little bit. So let me start out, and I'm going to do my x-intercepts. So if I have an x-intercept where I'm crossing the x-axis, that means the y value is 0. So that's why covering that up works out. What you're doing is you're plugging in 0 for y. So I'm going to do 9x squared equals 144. I'm going to get x by itself. So I'm going to start out and I'm going to divide both sides by 9. We're going to get x squared equals 16. Now, when I take my square root there, don't forget your plus and minus. Your x-intercepts are going to be 4 and negative 4. And just let me label this real quick. That's my x-axis. That's my y-axis. So I'm centered at 0, 0. All these guys today are centered at 0, 0. So we're going to go 4 over to the right, and that's the positive 4. 4 over to the left, that's your negative 4. Those are our x-intercepts. I was writing too big, of course. So we're going to do our y's down here below this little squiggle I just did. Y-intercept is when the graph crosses the y-axis, which is an x value of 0. So we're covering that up, but really what we're doing is we're plugging in 0 for x. So I'm going to get 16y squared equal to 144. Divide both sides by 16 here. Y squared is going to be equal to 9. Now we're just going to take a square root to finish this off. and we're going to get plus and minus 3 when we take our square root. So that means when I go on my y-axis, I'm going to go up 3 and then down 3. And I'm just going to do my best. I'm going to make a little curve here, oval shape. It's called an ellipse. I did a really bad job there, sorry. There we go. And then your domain and range. Your domain is how you move from left to right on the graph. So let me just label these guys real quick. This was -4 and +4. This was -3 down here and +3 up here. So my x values, we start at -4 and then we move to the right, we get over to 4, nothing beyond that, nothing before that. So I'm going to say -4 less than or equal to x, which is less than or equal to y. I don't know, I just wrote y, sorry. 4. When you're talking about domain, you're talking about x. Now, when we're doing range, it's how the y values move, how we're going up and down. So my lowest value here is -3, and I move up to 3, nothing above that, nothing below that. So your y values, it's going to be -3 less than or equal to y, since we're talking about range, less than or equal to 3.
So those are ellipses, and I know our drawings aren't the best. I just want to show you a picture of an ellipse from the textbook on page 534. This would be a real ellipse right here. That's as perfect as you can get. So if that's a real ellipse, next up we're going to talk about hyperbolas. A hyperbola is kind of like a double parabola facing left and facing right, but they don't always have to face that way. A hyperbola can be facing up and down as well. So I like to teach it like this in class. I show my students that if you notice these two examples here, there's plus signs on both of them. That's actually the reason it makes it the ellipse or circular shape. The next two examples, notice how they both have subtraction. That subtraction, what it actually does is it takes your ellipse and it cuts it in half and takes your ellipse and faces them in opposite directions. So your ellipse can go left and right or up and down, like that. So just kind of a visual that goes along with it. All right, here we go. Next example, x squared minus y squared equals 4. I want to go ahead and graph this. I know right off the bat it's a hyperbola. I'm going to start by finding the x-intercepts by substituting 0 in for y squared. I'm just going to cover this up. I get x squared equals 4. Square root both sides. X is going to equal positive -2. So my intercepts must be at positive -2, 2 to the left and 2 to the right. Now something funny is going to happen when I go to find the y-intercepts. If I substitute 0 in for x, I'm going to be stuck with -y squared equals 4. If -y squared equals 4, well, that negative is going to cause a problem for us. So if I divide both sides by -1, I get y squared equals -4. But when I square root both sides, some of you smart cookies are going to say, well, y must equal plus or minus 2i. And that's great if you remembered that, but there's no way for us to graph 2i on a grid. So what we're going to say is there are no real y-intercepts. And if you remember the shape of a hyperbola, the hyperbola for this equation are going to face east and west. You're going to have an open end going to the right, arrow tips because it never ends, and your hyperbola is going to open to the left as well. Those two branches, we call them, are going to never cross the y-axis, right? That's because there were no real y-intercepts. So that's your basic shape of a hyperbola. It's just a quick stretch. We don't know how thick these are going to be, how fast they're going to grow. So this is just a quick sketch of what that hyperbola looks like. The domain and the range are going to be a little more tricky now because of all this gap in the middle. So what we're going to say here is the range is going to be all your x's less than or equal to -2, or all your x's greater than or equal to 2. you've got to kind of write two separate parts of your domain, because you have to account for all the numbers to the left and account for all the numbers to the right, and there's nothing in the middle. Now for your range, if you look from top to bottom, or from the bottom up to the top, this graph will continue to grow boundless